Number one, Nicola throws an ordinary fairy six-sided dice. The random variable x is the number of throws that C takes to obtain A6. Find the probability x less than 8. That x is the number of throws to get the first 6. That is x. And we are find the probability that the first 6 occurs on the 8th throws. Now, let P is the probability of success on a single trial. If getting a 6, it means this is P, and then the P equal 1 over 6. Then 1 minus P equal 1 minus 1 over 6. It is 5 over 6. And using the cumulative probability, the probability x is an 8 equal the probability x1, x equal 2, so on until probability x equal 7 because less than 8 or probability x less than 8 also we can find through 1 minus the probability x greater than or equal 8. That is. And the probability x greater than or equal 8 is the probability of not getting a 6 in the first 7 throws. So this one. Right. Now, so the probability x greater than or equal 8, it is 5 over 6 to power 7. So it means this probability equal, this probability x less than or equal 8 equal 1 minus 1 of 7, 1 minus 70,125 over 279,936. And this result is 0.72091. Round off 0.721. So B, find the probability that Nicola obtains A6 for the second time on her 8th throw. So this is a negative binomial distributions problem. And now we are going to using the negative binomial formula x for this combination 1 minus p power x minus r, which x equal 8, r equal 2 as the second 6 according to this information for the second 6 for the second time. Okay, so it means the probability x equal 8 equal, this is x 8 minus 1, 7, and r minus 1, 2 minus 1, 1, the combination 7, 1. The probability 1 over 6 squared because r equal 2, and this is 5 over 6, 8 minus 2, 6. And if you calculate, this is 7, because this combination equals 7 times 1 over 6 times 5 power 6 and 6 power 6. And if you calculate, the result is 0.065119 round off 0.0651. This one. Number two, the random variable x takes the values minus 2, minus 1, 0, 2, 3. It is given that the probability x equal x, k times x squared plus 2, where k is a positive constant. Draw up the probability distribution table for x, giving the probabilities as a numerical fraction. The random variable x are this one, okay, and the probability mass function is this one, okay. So now we are going to compute the unnormalized probabilities and normalize. I will create the table x, and then this is x squared plus 2. X are minus 2, minus 1, 0, 2, 3. It means if minus 2 squared plus 2, 6, minus, this is minus 1 squared plus 2 is 3, 0 is plus 0 squared plus 2 equal 2. And if 2 squared plus 2 equals 6, and if 3 squared plus 2 equals 11, this one, 11. This table, you can create your table, and then the next step, we're going to find k. Okay, k, we can find k through k times 6 plus 3 plus 2 plus 6 plus 11 equal 1. So it means this is 28. K equal 1. So we can determine k 1 over 28. Scroll down. And the next step, I would like to create the table, the distribution table x, and then this is the probability x, x. Okay, minus 2, and then minus 1, and 0, and 2, and then 3. If minus 2, this is minus 1 over 28, k times 6 is 1. Yeah, k is 1 over 28, so 1 over 28 times 6, and it is 6 over 28. This is 3, 14. First one, 1 over 28 times minus times 3. Okay. Plus times 3 is 1. So this is 3 over 28. This one is 0. This one is 2. It means 1 over 28 times 2. 1 over 14. 1 over 14. And then go down. After that, 2. Sorry, I have to look. 1 over 28 times this one. 6. Yeah. So 6 over 28. This is divided by 2, 3 over 14. Yeah. And 3, this one, 11. So 11 over 28. So this is uh, the table. Yeah. Okay, next, continue. The next question B, find the value of variance x. Go down. For the variance x formula is ex squared minus ex squared, like this. So I would like to find ex first. Ex equals sigma x times the probability x, well, x. Okay, so it is minus 2. You can see on the table 14 and plus minus 1. It I have to and then times 3 over 28 plus 0 times 1 over 14. Sorry, my cell phone ringing. 3 times 1 over 28. This is 0. So it's going to be minus 6 over 14 minus 3 over 28 plus 6 over 14 plus 3 over, yeah, this is 11, sorry, over 33 over 28. It is 0. So it's going to be 30 over 28, 15 over 14. And after that, ex squared. Ex squared. Ex squared is sigma x squared x equal x. So this is minus 2 squared, 3 over 14, minus 1 squared, 3 over 28, plus 0, 2 squared, 3 over 14, 3 squared, 11 over 28. Right? And if you calculate, this is the result 150 over 28 or 75 over 14. So the variance x 75 over 14 minus 15 over 14 squared. So it is 75 over 14 minus 225 over 196. It is 1,200, 1,000, 1,050 over 196 minus 225 over 60, 96, and it is if minus 5 and then 2 and then this is 8. And the next step is 4, 41 over 196, or decimal number 4.21. So, next, number 3. The time taken in minutes to walk to school was recorded for 200 pupils at a certain school. These times are summarized in the following table. Draw the cumulative frequency graph to illustrate the data. Okay, I would like to, from this, if this is the origin, okay, okay, this is 0,0 origin. So I would like to, if you look this table, so the coordinate point we should set, this is 15, I was 15, 15 and 18. After that, 25, 25 and this one, 46, and then 30, 88, 40, 140, 50, 176, and then 70 to 100. Okay. So we're going to sketch this coordinate point. The 70 it means this is 1, 10, 20, 30, 40, 50, 70 here. Okay. Right. Because the maximum x is 70. And then the maximum of, right, of this axis is 200. So I have to sketch this. 100 means becomes 20 here, 40, 60, 200. Cannot. So it becomes 40. This becomes 40. So 80. And then it is 120. And this is 160. This is 200 here. Okay. Okay. So first 15 and 18. 15, this is 10, 15 here, and 18, this is 20. It means around here. I would like to use in the different color. Okay, this is first, and then after that, the next point, 25, 46. Okay, 25, 46. 25 here, and 46, this is 40, 50, 46, 55 around here. Okay. And the next is 30 and 88. This is 30 and 88. This is 80, 90, 88 around here. Okay, and then I want to see 40 and 140. 40 here and 140 is 120, 140 around here. Around here, 140. And 50, 176. 50, 176. 60, 160, 180 here, 176 around here. Okay, here. And then 70 and 200. 70 and 200. So it's 170. 70, okay, and 200 here. So that we create the graph. The graph. Okay. You can create your own graph. This. Yeah. Next question. Use your graph to estimate the median and interquartile range of data. Okay. So on graph, we need to find the median or Q2 median from 0 to 100. It means 0 to 200. It means median on 100 and 100 around here. Okay, and if we look 100 at 100, well, it's the different color. One, it's 100 here, 100 located here. Okay, so the Q3 or the upper quartile between 100 and 200, so it means 150. 150 around, this is 120, 140, 150 around here. Okay, 140 around here. Wait, I have to turn off my cell phone first. Already stopped. So 140, if we look this around here, 40, this is 42, around 42 here. Okay, around 42. So the upper quartile or Q3, 42. And then the lower quartile between 0 and 100. So it's 50. It is 60, 50 around here. Around here, 50. So this is around 26. Yeah. You look the detail, this is because it's 25 here and around 26 here. So it's going to be 26. So the interquartile or IQR for 42 is 26 and it is 16. Next. Calculate an estimate for the mean value of this time taken by the 200 pupils to walk to school. Okay, so from the cumulative frequency table on the part A, on the questions, we can create the new, I would like to create the new table about this one, the class interval. The class interval are T 0 to 15 and then T 15, 25 and T 25 to 30. This interval based on the information on the table. 40 is 30, 50, 40, 70 is 50. And after that, the next column, the cumulative frequency. The cumulative frequency, 18, based on the information, 46, 88, 140, 176, 200. And then class frequency. Class frequency, wait. Okay, sorry for the cell phone. I would like to continue the class frequency. 18, and then this one 40, 46 minus 18, 28, and this one 88 minus 46, 42, and this one 140 minus 88, 52, and this one 176 minus 140 is 36, and this one 200 minus 176 is 24. Okay. And after that, I would like to, based on this table, I would like to create the new table also for calculate the midpoints and the products. Right. The new table plus interval 0 to 15, 15 to 25, 25 to 30, 30 to 40, 40 to 50, and 50 to 70. And the midpoint for x 7.5 because 15 divided by 2, this one 15 plus 25 divided by 2, 20. This one 25 plus 30 divided by 2, 27.5, 35, 45, 60. And f, based on the information, this is 18, 28, 42, 52, 36, 24, and the sigma is 200. After that, f times x, 7.5 times 18, 135, 560, 1,155, 1,820, 1,620, 1,440. And this is 6,730. So mean equal 6,730 divided by 200. 33, 13 over 20, or 33.65. This one. This is mean. Number 4, Rahul has 2 bags X and Y. Back X contains 4 red marbles and 2 blue marbles. Back Y contains 3 red marbles and 4 blue marbles. Rahul also has a coin which is biased so that the probability of obtaining a head when it is thrown is 1/4. Rahul throws the coin. If he obtains a head, he chooses at random a marble from back X. He notes the color and replaces the marble in back X. He then chooses at random a second marble from back X. If he obtains a tail, he chooses at random a marble from back Y. He notes the color and discards the marble. He then chooses at random a second marble from back Y. Find the probability that the 2 marbles that Rahul chooses are the same color. Right. So back X has four red marbles and 2 blue marbles. BM it means blue marbles. So total 6 marbles. And back Y back Y has 3 red marbles and 4 blue marbles. So total 7 marbles. And after that, coins for the 1 coin. Okay, 1 coin is only 1 coin. He has 1 coin. For the probability of head is 1/4. It means the probability of tail 1 - 1/4 equal 3/4. Next, the next step, the probability that both marbles are the same color and coins shows the head. We can find through, I would like to writing the probability R, it means red, plus the probability B it means blue, times the probability of head. This is for the probability that both marbles are the same color and coins shows head. So this is probability head. So if we calculate, this is the result, 4/6 times 4/6. This is with replacement. 2/6 times 2/6 times 1/4 because head is 1/4. So the calculations will be 16/36 plus 4/36 times 1/4, and it is 20/36 times 1/4, and it is 5/36. And the next step, so it's 5/36. The next step, the probability of 2 marbles being the same color from back Y and without replacement, and the coin shows tail without replacement, and the coin shows tail. So the probability like this one, this is the second. The probability, this is without replacement, and the coin shows tail times the probability tail. If without replacement, so on back Y, so it's going to be 3/7 times 2/6 because without replacement on back Y, and After that, 4 over 7 times 3 over 6. Tail, it means 3/4. So it's going to be, this is 1 over 7, because 3 times 2 divided by 6, plus 2 over 7, 3/4. And the result is, this is 3 over 7, 3 becomes 3 over 7, 3 over 4, 9 over 28. So it's 1, the result, and this one. 5 over 36, and 9 over 28. And we can calculate that the probability for the same color equal 5 over 36 plus 9 over 28. Set this fraction becomes the same denominator, and the denominator is 252, and the result is 116 over 252, or 29 over 63. And I would like to write it in decimal. The decimal number is 0.460. Next question. B. Find the probability that the two marbles that Rahul chooses are both from back Y, given that both marbles are blue. We are looking for a conditional probability. And the probability back Y, given both marbles are blue. So back Y, blue, blue, like this. Okay. So using the bias theorem, the probability of back Y given blue, blue, the formula, probability blue, blue, double blue, back Y, given back Y, minus the probability back Y, okay, divided the probability both blue, or blue, blue. Next, I'm going to find the probability, this one, double blue and back Y. Probability back blue, blue, given back Y. So this is 4 over 7 times 3 over 6. It is 12 over 42 divided by 6 divided by 6, 2 over 7. This is without replacement, or this event without replacement. And the next event with replacement, the probability blue back X. Better if right here, this is without replacement. Yeah, so, and this is with replacement. With replacement, 2 over 6 times 2 over 6 equal 4 over 36. It is 1 over 9. This is without with replacement. This is without replacement. Sorry, this is without replacement. This is with replacement. Yeah. Okay, next, I'm going to find the probability blue, okay, double blue, it equal probability of head times the probability blue given back X plus the probability tail times the probability double blue given back Y. One. So it's going to be 1/4 times 1/9 plus 3/4 times 2/7. So it becomes 1/36 plus 6/28. So it is, we said becomes the same denominator, 7/252 plus 54/252. So it is 61/252. Based on the Bayes formula that the probability back Y given double blue, it is 2/7 times 3/4 over 61/252. It is 6/28 over 61/252. This is 6/28 times 252 over 61. Divided. This is 9. So 6 times 9, 54 over 61. Or it is 0.885. Next question. Number 5. I'm going to change become 5 becomes black on the color. Wait. Number 5. The weight of the green apples sold by a shop are normally distributed with mean 90 grams and standard deviation 8 grams. Find the probability that a randomly chosen green apple weighs between 83 grams and 95 grams. Right. So based on these informations, we have the information that mu equal 90 grams, and then the standard deviations equal 8 grams. Okay. We want to find the probability that an apple weighs between 83 grams and 95 grams. Or I would like to writing that the probability of X greater than 83 less than 95. This probability we are going to find. The first step, convert to standard normal distributions or C-scores, and we are going to using the C-score formula. The C-score formula like this, C equal X minus mu over the standard deviation. So for, this is the formula, okay, for X equal 83, it means C equal 83 minus 90 over 8, okay, and this is 0 minus 0.875. And for x95, 95, z equal 95 minus 90 over 8, And if you calculate, the result is 0.625. And the next step, find the probabilities using standard normal distribution table, or you can using calculator. That the probability Z less than 0.625, it is 0.7340. Again, you can using your calculator or standard normal distribution table. And the probability C less than minus 0.875 equals 0.1908. Next step, calculate the probability between the two C scores. Means the probability X greater than 83 less than 95. And it is the probability Z less than 0.625 minus the probability Z less than minus 0.7875, and it is 0.7340 minus 0.1908, and the result is 0.5432. Next question. P. The shop also sells red apples. 60% of the red apples sold by the shop weigh more than 80 grams. Another 60 red apples are chosen at random from the shop. Use a suitable approximation to find the probability that the fewer than 105 of the chosen red apples weigh more than 80 grams. 90% of red apples weigh more than 80 grams. So it means we can writing that the probability P equals 0.6. And then 160 red apples are chosen. So it means N equal 160. Let X be the number of the red apples out of 160 that weighs more than 80 grams. Then, again, writing that X for the binomial distribution, N equal 160 and 0.6. This is the probability. Since N is large and P is not too close to 0 or 1, we can use the normal approximation to the binomial distribution. So it is X, the normal distributions, mu, and variance, like this, where mu equal NP, N times P equal 160 times 0.6, it is 96. And this is the standard deviation is square root, okay, NP P square root, NP is 160, so 1 times NP times 0.6, 1 minus P is 0.4, 1 minus 0.6, and it's going to be square root 38.4. It is 6.19677, or 6.2. This one. Next, for the next step, we're going to find the next step, probability x less than 105. And it apply continuity corrections, going to be probability x less than or equal 104.5. This apply continuity correction. So convert, after that, the next step, convert to a C-score. So it's going to be C 104.5 minus 96 divided by 6.2, 8.5 over 6.2. It is 1.370967 of 1.37. And the last step, we are going to find the probability using standard normal table, or you can using your calculator. So the probability C less than 1.37, it is this one 1.37. Using calculator or your standard normal table, you can gain 0.9147. So the probability x less than 105, it is 0.9147. This one. Number 7. The heights of the female students at Griffin College are normally distributed. 90% of the female students have heights less than 182.7 centimeters. 40% of the female students have heights less than 162.5 centimeters. Find the mean and the standard deviations of the heights of the female students at Griffin College. So 90% of the heights are less than 182.7 according to this information. And 40% of the female students have heights less than 162.5 centimeters according to this information. Right, from the standard normal distributions, the C-score for the 90 percentile, this is, so actually this is 90 percentile, 90th percentile, and this one is 40 percentile. Right. So the C-score for the 90 percentile, it is 1.2816. This is the C-score for 90 percentile. And for the 40th percentile, the C-score for the 40 percentile, it is minus 0.2533. And the next step, using the C-score formula, C x minus mu over sigma, it is, we can find two equations through this formula. The first equation we got from, wait, I'm gonna separate this formula. The first equation is 100 182.7 according to this information minus mu over sigma equal 1.2816 according to this information. So we can rearrange this equation, becomes 182.7 minus mu equal 1.2816 times sigma, or mu equal 182.7 minus 1.2816 times sigma. And the second is 162.7 minus 1 point, okay, 1.28, sorry, I mean one minus mu, okay, like this one, minus mu. It is minus 0 point, according to this information, 2533, and it's going to be 162.7 minus mu equal minus 0.2533 sigma. And it is, so mu, you can rearrange mu equal, if this one move up, becomes plus 0.5 plus 0.2533 sigma. Okay, it is mu, this is mu as well, right? So we can determine sigma or standard deviation. So mu equal mu, which means 182.7 minus 1.2816 sigma equal 162.5 plus 0.2533 sigma. And the next step is going to be 1.2816 sigma plus 0.2533 sigma equal 162.5 minus, wait, this is 182.7 minus, okay, smooth, yeah, 27 minus this one, 162.5. So if we calculate this number plus this number, it becomes 1.5349 sigma equal, if this one becomes 20.2. So we can determine sigma equal 20.2 over 1.5349. And the result is 13.160466. Round off 13.2. This one, 13.2. So this is the standard deviation. So standard deviations, or this is sigma, standard deviation is what? 13.2. Now we're going to find mu or mean. Based on this result, I would like to using this equation, this equation. Mu 182.7 minus 1.2816 have standard deviation. So it's going to be mu equal 182.7 minus 1.2816. times 13.1604 on. So mu equal, if you calculate this is 165.8335, or round off, mu equal 165.83. Yeah. So this is mean, this is the standard deviation. Next question. 10 female students are chosen at random from those at Griffin College. Find the probability that fewer than 8 of these 10 students have height more than 162.5 centimeters. Right. So we can state that from the previous solution, or the previous questions also, that the probability of height less than 162.5 is 0.40. So the probability, the height greater than 162.5, it is 1 minus 0.4. So it is 0.60. That is. Now, we randomly choose 10 female students. And the next step, let X be the number of students out of 10 with height more than 162.5 centimeters. Then I would like to writing that X binomial distribution B here, binomial distribution 10 and 0.6. 10 because of n equal 10, 10 students, this is n, and then 0.6 because of the probability high more than 162.5 or greater than 162.5. This binomial distribution. So it means you want to find, based on these questions, you want to find the probability. You want to find this, the probability X less than 8. This. Okay. Now, the probability X less than 8 is equal the 1 minus the probability X equal 8 plus the probability X equal 9 plus the probability X equal 10. Okay. And then using the binomial theorem, we're going to find the probability of X equal 8, X equal 9, and X equal 10. 8 first. This is the combination 10, 8 times P 0.6 or 8, 1, and 1 minus P 0.4. Okay. And this is 2 because 10 minus 8. And if you calculate, the result is 0.1209. And then the probability X equal 9, combination 10, 9, 0.6 power 10, 0.4 power 1. And if you calculate, the result is 0.0403. And then the probability X equal 10. Scroll down first. Probability x equal 10, the combination 10, 10, 0.6 power 10, 0.4 power 0. And if you calculate the result is 0.0060. So it means this probability x less than 8 equal, this probability is 0.1209. This probability is 0.0403, and this probability is 0.0060. And if we calculate 1 minus, I mean, so it's 1 minus, I forgot. X less than 8 equal 1 minus. So it's going to be 1 minus this. I have calculated this already, and then equals 0.8328, or it is 0.833. Next question. 7. How many different arrangements are there of the 9 letters in the word intellect in which the two T's are together? It means double T. Okay, letters in intellect consist of T, 2, and L as well, 2, and E also 2. So N, and C appears once. Okay. So now we treat that TT, according to this information, TT as a single unit. So the grouping, I will have to write in the grouping. The grouping becomes T, I, N, E, L, L, E, C. And it is 1, 2, 3, 4, 5, 6, 7, 8 units. 8 units. Right. And the steps, repetitions among the 8 units, I'm going to write it here. The repetitions among the 8 units, L appears. L appears twice, and E appears twice also. So L appears twice, E appears twice. You can look at L twice and E also twice. Right. So we divide by the factorials of repeated items into L and E, 2 and 2. So we can state that the number of different arrangements, number of different arrangements based on this question, we can determine through 8 factorials over, this is L as 2 and E 2 as well. 8 factorials over 2 factorials times 2 factorials. And if you calculate this, is 40,320 over 2 times 2, 4. And the result is 10,080. This one. Next question. How many different arrangements are there of the 9 letters in the word intellect in which there is a T at each end and the two E's are not next to each other. Okay, after using the two T's, we are left after two T, we are left only one, two, yeah, seven. Okay, we are left the seven letters with E two times and L two times also. L, L. Okay. Now, we are going to compute total middle arrangements. Total middle arrangement. So total middle arrangement 7 factorials over 2 factorials times 2 factorials. Okay. Uh, let's continue because uh, I will calculate this. I will using this fraction for the next calculation. And the next step, treat the two E's as block EE. Then we are arranged that EE as one unit. One so becomes I N L L C. Okay. So the total this is 5 units. And then total 6. So this is 1 unit and this is 5 units. So total 1 and 5, 6 units. 1, 6 units. And L appears twice. Okay. Now, so the number of arrangements with is together. Writing here, number of arrangement with is together is because double E is 6 factorials over 2 factorials. Okay, because of this is 6 units. And then total number of different arrangements, we can determine number of different arrangements for 7 factorials over 2 factorials minus 6 factorials over 2 factorials, and it is 5040 over 4 because 2 times 2 minus 720 half. And if you calculate, this is 1260 minus 360, it is 100. Next question. 4 letters are selected at random from the 9 letters in the word intellect. Find the percentage of the possible selection which contain at least one E and exactly one T. The total number of 4-letter selection we can determine through the combination 9, 4, and it is 126 if you calculate on your calculator. Now, the next step, selections with exactly one T, okay, one T, and one E. Okay, one T and one E, or the letters will be T, E, and the next letters. Right. Now choose one T like this. I writing like this from two, and the combination two one, and then choose one E from two as well. The combination two one, and after that choose two more letters. Choose two more letters from the remaining five letters are non-T and non-E. Five letters are non-T and non-E, I, N, C, L, L. So 1, 2, 3, 4, 5. So the combination becomes 5 and 2. Okay. So number of selection, we can determine the number of selection of this part. Number of selection of this part is a combination 1 times combination 1, the combination 5, 2. This is 2 times 2 times 10. It is 40. Okay, next. Selection with exactly 1T. Okay. Selection with exactly 1T and 2. And 2 is the difference. This is 1T and 1E, but this one 1T and 2 is. So the letter will be T, E, E, and the next letter. Now choose 1T from 2, and the combination 2, 1. I need more space. And next, choose 2E from 2, the combination 2 and 2. And after that, choose one more letter from the 5 others. Okay, from the 5 others, I, N, L, L, C, 5. So it's gonna be combinations 5, 1. So number of selections of this part, number of selection, combination is 1, 2, 1 times combination 2, 2 times combination 5, 1. The result 2 times 1 times 5, and it is 10. So we can determine the percentage based on the question. The percentage 40 plus 10 over 126, that's 100%. And the result is 39.7%.